Section 2. Predictions. 2.1. Super Forecasters. In his book, Expert Political Judgment, Philip Tetlock looked at a sample of 177 super forecasters. These are people who predict all manner of political events that are put on political betting markets and are able to make money doing so. Examples of things they bet on would be elections, but also things like the extent of the Arctic and Antarctic ice sheet, how many troops the US will have in Iraq or Afghanistan by a certain date, etc. And these people make objective predictions, which are scored. They can't be vague predictions like the US will pull out a lot of troops. One has to specify how many and by what date. And scores have to be standardized across different topics. For example, comparing number of troops to square kilometers of Arctic ice, the degree of variance in those things have to be standardized so that a predictor can be scored on the same scale for both topics. How well someone does with their predictions is called their Bria score. Forecasters with a Bria score above a certain value are labeled by Tetlock super forecasters. See Table 3.1. What Tetlock found was illuminating. Education had no effect. Years of professional experience had no effect. Being an academic or non-academic had no effect. Contact with media had a small minus 0.12 effect, with greater media exposure resulting in less accurate predictions. Females were 5% more accurate, and the correlation between self-rated expertise and predictive accuracy was 0.09. Left-right political orientation had virtually no effect, nor did seeing yourself as an idealist or realist. The doomster-boomster dichotomy did have a significant effect, with boomsters, economic and environmental optimists, predicting with 20% greater accuracy. The point of the book was on the hedgehog versus fox thinking style, which is that the fox knows about a lot of little things, while the hedgehog knows one big thing, which is to say, the hedgehog thinker has a more coherent overarching worldview. A hedgehog on economic questions would be a Marxist or a Friedmanite free marketeer, and foxes were 35% more accurate than hedgehogs, a huge effect. Those with more extreme predictions made better predictions, and those with more integratively complex thought protocols made better predictions, which means people who had a system of formal rules in their thinking did better than those who didn't. And Tetlock's book is very interesting, and very little of his book is about highlighting the irrelevance of formal expertise. He mentions it in passing, but while not Tetlock's focus, that is something incredibly important to society, that among the super forecasters, credential is virtually irrelevant. Even when the credential is on the topic being predicted and the forecaster rates his expertise highly as a result, the increase in accuracy of prediction compared to the rest of the forecasters is only 9%, which is a smaller effect than just being an optimist or not having your brain rotted by news media. So, be more of an economic and ecological optimist, stop watching the news media, be less ideological, less of a hedgehog and more of a fox, develop some formal rules of thinking, or at the very least sound out your arguments, and that will do far more for your ability to predict the world in a general sense than a credential will, which at most will mildly increase the accuracy of your predictions in a narrow set of topics. You may want a credential for other reasons, but it's not going to make you more knowledgeable about the world in any testable way on difficult and contested questions. Now, this is not to say that non-PhDs are just as good at predicting things as PhDs. They may or may not be. We would guess PhDs would be better at predicting things. The data on super forecasters merely compares non-PhD super forecasters to PhD super forecasters. That is, among the population of super forecasters, having a PhD doesn't matter. PhDs may, literally may, be more likely to reach the threshold of super forecasters, but once you pass that bar, it doesn't matter. 2.2 Statistical Prediction Rules. An old paper from the year 2000 looked at comparing statistical prediction rules versus field-relevant experts, and compared the standardized accuracy of these prediction rules versus certified clinical experts. This is from the paper Clinical versus Mechanical Prediction, a meta-analysis. The researchers looked at 136 studies with that comparison. The categories were educational, financial, forensic, medical, and clinical personality. And in all categories, the mechanical prediction outperformed the clinical prediction. The authors then organized the results into 5 categories. See tables 1 and 2. Educational, financial, and clinical personality had smaller gaps between experts and algorithms, with a gap of 0.09, 0.20, and 0.19 standard deviations respectively. For forensic and medical predictions, the gaps were 0.89 and 0.82 standard deviations respectively. Moreover, the authors note, in instances where clinical experts had access to the statistical prediction rule, the statistical prediction rules still won. When the clinical experts had access to more data than the statistical prediction rule was using, the statistical prediction rule still won on average. Even when the experts had access to both the statistical prediction rule and more information than the SPR used, the SPR still beat out the experts. Now, these statistical prediction rules were of course developed by experts themselves, but the fact is, a layman with access to these statistical prediction rules would be able to outpredict a clinical expert in these fields most of the time. This was from the year 2000, and so, in all likelihood, the gap is larger today. 2.3 Financial Predictions. From the paper Diagnostic Expectations and Stock Returns, the researchers looked at how well financial analysts predicted stock portfolio return from the years 1981 to 2015. See graph below. They were ordered based on what the financial analysts predicted was high long-term growth and low long-term growth, with the stocks predicted as having the lowest rate of return having the highest rate of return, and stocks with the highest rate of return having the lowest rate of return. Now, when one thinks of academic credibility, they are usually not thinking about financial analysts. But financial analysts are a good litmus test because, once they get their degrees, they then have to go out into the real world and perform. And they perform very poorly, significantly worse than random guessing. The old adage of a dart-throwing monkey being as good as a financial analyst is simply false. The dart-throwing monkey would radically outperform the financial analysts. And the cope that this is only true over the short term is false as well, as this paper looked at a random sample of financial analysts from 1981 to 2015. Part of the reason financial analysts are taken less seriously than other academics is that, unlike other academics, they have to actually get out and make hard predictions with unambiguous outcomes. A sociology professor does not. In fact, even a biologist does not have to make these kinds of predictions. 2.4 Behavioral Economists versus Mechanical Turk. Amazon has a program called The Mechanical Turk, which links up people, usually poor people from a poor country, who can be paid to do a long series of monotonous tasks on a computer, filling out forms, lists, tables. A behavioral economist is a kind of psychologist who predicts how people will behave in economic contexts, what they will buy, where they will try to work, what they will invest in. The paper Predicting Experimental Results, Who Knows What, by Vigner and Pope, compared how a sample of opportunity, people they could get to participate in the study, predicted how much effort different groups of people were willing to put into various tasks. They compared PhDs in behavioral economics, PhD students, undergraduates and MBA students, and Mechanical Turk workers. The Mechanical Turk workers are anonymous, but a 2009 paper showed that, at least 11 years ago, 57% of them were from the US, 32% from India, and the rest from Romania, Pakistan, UK, the Philippines, and Canada. In terms of the average accuracy of the forecasts, the Mechanical Turks were substantially worse with a higher mean error. However, when all taken together, the overall correlation between Mechanical Turk workers' assessment and actual effort of the target was 0.43, compared to 0.51 for PhD students, 0.49 for undergraduates, 0.45 for academic experts, and 0.42 for MBA students. Consider also that some proportion of Mechanical Turk workers will just click buttons to get their 10 cents and not bother trying to make accurate predictions. A random guy making a prediction about something is at least a volunteer. He's volunteering his prediction. He's putting some effort into it. The same cannot be said for every individual Mechanical Turk worker. And so this comparison of behavioral economists to Mechanical Turks should be taken with a grain of salt, i.e., the Mechanical Turks are probably less accurate than highly motivated amateurs. One could respond that the academics and academics in waiting these Mechanical Turks are being compared to could also lack motivation in their predictions, or their speciality may not be geared towards making predictions about individual effort in tasks. Well then, that makes the point just as well, which is that the academic training itself is not the relevant factor, but the individual person's knowledge. Now let's be clear, the academics did outperform the Mechanical Turks slightly, but not to such a degree that you should take the credential of behavioral economist as the last word on ability to predict economic behavior. The PhD students only had a 0.8 greater correlation with the outcome here than the Mechanical Turk workers. Now, if instead of Mechanical Turk workers you had highly motivated amateurs, and instead of an opportunity sample of PhD behavioral economics students, you had PhD economics students who set out specifically to study this problem voluntarily and without prompting, the accuracy of both groups might be higher. But certainly the results of this experiment shouldn't make one leap to the conclusion that PhD students, the best predicting group, intrinsically motivated about a topic, would make better predictions than a highly motivated amateur on that topic. And it seems intuitive that the gap between highly motivated amateurs and Mechanical Turk workers is greater than the gap between an opportunity sample of PhD students and PhD students intrinsically motivated about a topic.